This series of videos looks at weaknesses that I discovered on my website after it came under attack by hackers, and the steps I went through to remove those weaknesses and to harden every aspect of my server and my applications. The moment you make your website public, the bots immediately start scanning it for weaknesses. Environment variables, hunting for standard weaknesses, WordPress, WordPress sign-in, WordPress admin, WordPress, GitHub, environment variables, configuration files, API file. All of these things are potential weaknesses that the bots are constantly exploiting. Whether you are a system administrator, a developer, or a solopreneur who doesn't know anything about the back end, or simply the manager of a company that has a website, you need to be aware that your website is constantly under attack by bots searching for well-known attack vectors. If you don't have the skills or the desire to secure your website yourself, you need to engage someone who does. In this video in the series about cybersecurity issues that I've encountered, we're going to look at the concept of deployment models and deployment isolation. This was a big problem in the configuration that I had, and ChatGPT has helped me correct that. So in the original configuration, we had a directory, say under var/var/www/abc, and underneath that directory was the Git repository and controls and version controls and change control directory. There was the production source code. There was all of the dynamic files, files that customers would upload, documents, images, anything that was generated by AI would all go in there. The database definition SQL file was in there, maybe some documentation, maybe some AI.md files were in there. All of the log files, debug logs, Apache logs, application logs, credit card processing, payment processing logs, the vendor files, which are packages of applications that certain vendors supply that the code needs, and Apache was the user that had access to all of this stuff, so it was under the user www-data, and this is a standard user for websites. On Linux systems generally it's www-data, that's what it's for, and Apache is the user that runs that. So someone comes in, so normally it would come in as something like that, so they just type in xyz.com. The DNS redirects them to port 443 of this server, and Apache converts xyz.com to /var/www/abc, comes down here and searches for index.html or index.php. However, because everything is mixed underneath the one directory, and all the Git files are there, and basically everything, all the log files were there, and everything was accessible to Apache, the Apache server, someone could come in and say /git.config, and Apache would happily go into the Git directory and serve up the configuration file, which would instantly give them access to everything, all the source code, all the history of the source code. So even if you, like during the initial development and debugging, you hard code a password or an API key and then delete it later before you go live, it's still there in the history, and someone could go through this file system and find an earlier version of that program that had the API key exposed. Also .env files. In AI applications, people use .env files for a lot of stuff. I don't, so they would put environment variables, so, and someone could go .env or something else. And we saw in the previous video how hackers or bots, hacking bots, were going through, were accessing my website, and they were looking for all the standard sort of files that they would expect to find on there. In the new deployment model, we have on the web server, so still underneath /var/www/abc, which is still accessible by Apache through the user www-data. That hasn't changed, and the production source code lives on there. Everything else has been moved out of that file system. Now the log files themselves, I have moved onto a separate drive. This is actually a different drive completely, and the reason for that is that if there was a DDoS, like denial of service attack, that was attempting to fill up the log files and therefore fill up the drive and cause the whole system to shut down, that actually wouldn't happen. You can fill up the log files now, and it's not going to shut down the system. It's not going to shut down Apache or the operating system. Even the application could keep working. It might get an error when it's trying to output something to the log file, but it's not going to actually stop working. And all of the dynamic files, uploads, documents, images, and anything that's generated by AI and sent back, that's stored in a separate area as well. And again, it's if there's some sort of a DDoS attack, that's not going to fill up the main drive and shut the system down. So for the actual deployment part, everything related to deployment is moved into its own area and is owned by a new user that was created, that all it's used for is deployment. The only access it has is to the deployment structure. So now underneath this deployment structure, we have the .git files or directory structure for the application, and then we have all of the builds for the application. So every time we make an update, pull it down, it goes into a new build directory structure, and the current build relinks to the new one, and then the rsync command is used to update the production source code with the new build. So if that release is broken, then we can instantly simply relink the current build back to the previous build. So we would just delete that, and so we go blah, and then link that to there, and that gets synced across into production. So then now if you're not a developer or system administrator, don't worry about the technicalities, just understand that all the components of your web application should be separated according to their function, and deployment is a completely separate function to serving the application to the customer. If a bot tries to do .git.config, Apache will go will come down to this directory and look for /abc/.git, and it will say not found. It'll come back with a 404 error, not found. And likewise, same with all the logs. If a bot tries to, or a hacker who managed to access the system while it was under development and it was under the previous structure, tried to go web.log, Apache would simply say look for var/www/abc/web.log, and would say, oh, it's not there. And again, it would return 404 error, not found. Now let's look at deployment isolation in some more details. So this is my working with ChatGPT. This is an important section because deployment isolation is one of those concepts that many small VPS owners, virtual private server owners, get wrong without realizing. So originally I had my website root directory where all the application is stored, and then under that I had .git, and underneath that, which is a subdirectory, underneath that was all the Git archives and history and control structures, with the live website directly connected to Git. Now that seems convenient, but it creates multiple risks. So what is deployment isolation? Separating development, source control, the build processes, and live production code. So a problem in one layer cannot compromise everything. So before hardening, my architecture looked roughly like this, which is what we're just looking at in the diagram. So when I make changes, I do to the code, I do that on my local PC. Then I push those changes to my GitHub repository. Then on the server, I do a git pull, and that pulls those latest changes down from GitHub into my application directory. And then Apache serves the live website. So meaning that my live production website was also my Git working directory. This sounds harmless, but it's not. Okay, problem one, the live website contains the .git directory, meaning that Apache server, live website, Git history, and deployment metadata all existed together. And if Apache was misconfigured even slightly, an attacker could request .git/config, which you saw on the Apache access log, or .git/head, which you also saw on the Apache access log. And once Git becomes downloadable, attackers can often reconstruct your source code, API keys, database credentials, historic passwords, or even current passwords, deleted files, which may be early versions of the source code, which contained API keys like for debugging purposes and configuration secrets. This is a very common attack, and the reason we saw these requests in the Apache access log was because it happens. So it is a common attack vector. So as ChatGPT said, I thought nobody would ever know these even existed, but bots scan for them continuously. Problem two, the live deployment had no rollback. When I do the git pull to bring down the latest changes onto the server, this modified the production site directly, meaning if GitHub had bad code, or an upload was incomplete, or a merge conflict occurred, or a dependency broke, or a syntax error, your live production system immediately broke. There is no safety net, no rollback, no staging, no versioned releases. And for example, if there was a fatal syntax error, then any access to that function of the website would return to the user 500 internal server error. And the live website would be offline with no easy recovery. Problem three, no immutable releases. Production code changed in place. We had no historical snapshots. Questions became difficult. What changed? Which deployment broke production? What did the code look like yesterday? There is no reliable answer to these questions. And If you're just running your own web server, then that's fine. But if you are charging customers to run their website and something broke and you couldn't answer these questions, then you could be in a lot of problems. Problem 4 was that permissions were mixed together. So remember, www-data is the user that Apache uses to access source code. So that's the user ID that it runs under. So all the source code needs to be accessible by that user ID, but Git needed to be accessible by me, by my user ID. So the permissions became, as it said, this creates permission confusion because all of these things exist under the same root file system of the website, and there was terrible permission confusion. So Git creates files that are owned by me, Apache creates files owned by www-data, and if there was a confusion between those or a mismatch, then suddenly the user was returned a permission denied or upload stopped working. Yes, as it said, you experienced versions of this problem. That's right, because it remembers all the problems that we worked to resolve together. Problem 5, runtime files were mixed with source code. So by runtime files, we mean upload directories, logs, cache, generated images coming back from AI, the vendor repository, which contains libraries of code that various vendors supply, such as SendGrid, Stripe, PayPal, and others. They live under the vendor directory. These are not my source code, but because everything lived together, Git deployment risked overwriting them. You discovered this when I did that, and the sync attempted to remove the vendor directory, right? And also what happened was that during my testing, so I've tested it, I got back generated images from Nano Banana or Gemini 2.5, I think, and they were stored on there. But because those images did not exist on my development machine, when I did a Git pull, Git saw that those images weren't on the GitHub repository, so it deleted them. Oh dear. So that was a problem. So that's another reason not to have things like generated or uploaded files living in the same directory structure as your runtime code or source code, indeed, because Git could delete them. That was a real-world lesson, indeed. I realized the deployment system was treating runtime files, like generated or uploaded images, the same way as source code. This is a common mistake. Problem 6, no blast radius reduction. In security, we think in blast radius, meaning how much damage can one mistake cause. Previously, one mistake could damage the Git repository, the live website, secrets, permissions, uploads, logs, or either damage or expose. By damage, we could also mean exposed to hackers all at once because everything was tightly coupled and permissions were confused. And as we saw in the diagrams earlier, so the new architecture goes GitHub, that gets pulled down into its own Git repository, which is timestamped, and that maps to the current, so that's linked symbolic linked. So that's symbolically linked to the current, which is then synced across to the live website, and each layer has its job. So layer 1 is the Git repository, lives on the Git directory. Purpose: it only contains source code. It is not web accessible. It can't be accessed by Apache. Even if you know what the directory is, a hacker can't access it because Apache doesn't have permission to access that directory structure. So it contains all of the Git history, branches, the structures, the commits. Layer 2 is the individual build releases. So these are immutable releases, and each one is time-stamped. So then you know exactly when each build was brought down from GitHub, and so you can easily roll back just by comparing date time. Layer 3 is the current symbolic link. So there's a directory, directory structure called current, which is symbolically linked to the latest Git pull. So that means we can redirect that symbolic link of the current directory structure back to a previous release. And then we have layer 4 is the actual live production application where all of the live source code lives. And its purpose is to serve production traffic to Apache, which then serves it to the user's browser. It contains no Git, no history, no secrets, no deployment logic. And although it says runtime files, in fact, that as per the diagrams I showed earlier, there is actually no runtime files and no uploads, just source code, nothing else. The biggest mistake I made was treating my live production website like a development environment, and that is very true. It was a mirror image of my development environment on my personal local PC. Production should be boring, stable, predictable, and isolated. That's the core lesson of deployment isolation. And there we have it for today's video. So even if that was far too technical for what you want or need, just be aware that deployment isolation is critically important to your security. And if you are just running a little website that doesn't store any financial information, doesn't have any secrets, doesn't have any customers, doesn't store any customers' data, then that's fine. No, you can allow it to be hacked and used. But if it connects to a payments processing platform such as Stripe, or an email interface such as SendGrid, or it stores customer data on a database, then you need to be aware that deployment isolation is one of those critical cybersecurity issues that needs to be addressed. And if you don't have the technical capabilities, technical skills to do it yourself, then you need to engage someone who does. All right, thank you. And if you'd like to just have a free, no obligation chat about your issues and the status of your website, send me an email, admin@synergen.net, and we can just have a quick chat and see if there's any way I can help you do an audit or fix up of your cybersecurity issues on your website. Okay, bye for now.